Okay, so we have looked at lines and we have looked at parabolas. So next we're going to move on to our conic sections, so circles, ellipses, and hyperbolas, and we're going to see how those can be in parametric form. So if you take a look at this chart right here, so rectangular form we're used to for a circle, we have x minus the h squared plus y minus the k squared is equal to r squared. In parametric form, for circles and for when we get to ellipses, they're going to have cosine and sine in them. So think about the unit circle and how we use cosine and sine on the unit circle, and that's where this is going to come from. So we will reference that chart again once we work through a few of these problems. So on this one, we have x minus 1 squared plus y squared equals 36. So this is in rectangular form. This is a circle. Just because I want to look at stuff at the end, just to think about this, we know that the center of the circle, since this is x minus 1, that's positive 1, and because it's y squared, it's be 0. And then if you remember the radius of the circle, you take the square root of that 36, so the radius would be 6. So we would have a circle with a radius of 6, a center of 1, 0. So we want to change this. This is rectangular form, okay? We want to change this into parametric form. So the formula you're going to have to use for circles is your Pythagorean identity cosine squared t. You can really use whatever letter you want, but cosine squared t plus sine squared t is equal to 1. So we're going to be using this Pythagorean identity, hopefully you know from last unit, when we're doing circles and when we're doing ellipses. So what we want to do is directly underneath this rectangular form, I'm going to write this cosine squared t plus sine squared t equals 1. Because we're going to be comparing these two equations. Now, one thing that you have to notice, cosine does have to go with the x value, because remember cosine is the x value in the unit circle, and sine has to go with the y. So just make sure if this is not in the correct order that you line them up with cosine with x and sine with y. So I want to compare the two things. So in order for us to be able to compare these exactly, like if you look here, these would both have to have a 1. So what I want to do first is I want to rewrite my circle equation so that this is a 1 here. So I'm going to divide every term by 36. So this is really x minus 1 squared over 36 plus y squared over 36, and now it is equal to 1. Okay, so because a circle is not equal to 1, you need to set it where it's equal to 1. That way we can have that part there. Okay, so now we're going to combine, or we're going to take a look and compare these two equations. So this tells us that cosine squared would have to be the same thing as x minus 1 squared over 36. So let's just write this down here. Cosine squared t would have to be equal to x minus 1 squared over 36. Okay, that has to be a true statement because these are equal to 1. So to get rid of the squares, I'm going to square root both sides. This would leave me with just cosine t. This would leave me with x minus 1, and the square root of 36 would be 6. Now remember with parametric equations, you have an equation for x and you have an equation for y. So we want to solve this equation for x. So I'm going to cross multiply, and we'll have 6 cosine t equals x minus 1. So if I want to get x by itself, we would just add over the 1. So 6 cosine t plus 1. A lot of times the 1 gets written in the front, but either way is fine. So this is my x equation for my parametric equation, okay? So we're going to do the same thing over here for the y. So we know that the sine squared t has to be equal to y squared over 36, and that's because we're comparing these two equations if they're both equal to 1. So I'm going to get rid of all the squareds first by square rooting. So sine t is equal to y over 6. So if I cross multiply, so now it is solved for y. So y equals 6 sine t. So now I have two parametric equations. Remember, parametric always comes in a pair, an x equation and a y equation. It is in terms of t here. This could say theta. This could really say any letter here. Just some parameter that is inside of there. But some things I want you to look at. So if you look back at the chart that we have here, for circles, you're always going to be looking for cosine and for sine. So some things to notice. This is a circle. These are the parametric equations. If you look in front of the cosine and in front of the sine, they should have the same number. That number here is 6. Well, where did that 6 come from? Well, the 6 is the radius. So whenever these are written in parametric equation, the radius will be the same number in front of cosine and sine, and that is your radius there. The center is going to come from what is added in the front. So see how there's a 1 here in front? So that's where the x-coordinate of the center is. And then there's really no term in front here. It would just be like 0 plus. That's where the 0 comes from. So when you have these in parametric form, you can actually tell a lot about the circle without having to put it back in rectangular form. Okay. So for our next problem, we're going to do the opposite. We're going to start out in parametric and we're going to change it to rectangular form. So the two equations we have here are 4 minus 2 cosine t and y equals negative 3 plus 2 sine t. Okay, so I want you to notice something here. Just from looking at the parametric equation, this is going to be a circle. Okay, there is this 2 here. All right, this sign here is not going to matter because of the square roots. So because of this 2 here, because they're both a 2 and they both have cosine and sine, we know it's a circle and we know the radius has to be 2. Okay, from this information you can also figure out the center. So the center with the x is 4 and with the y is negative 3. So before we graph, and it has a graph on there, let's check with our rectangular and make sure we get the same thing. But this is the information that we should end up with when we finish. Okay, so in order to do this, you're going to need that Pythagorean identity cosine squared t plus sine squared t equals 1. You're going to use this for circles when you're going from parametric to rectangular or rectangular to parametric. So what we're going to do here is before I can plug into this, I need to take my little equations and solve them for cosine and for sine. So if I take this top equation over here, and I want to solve it for cosine. So if I subtract 4, and then you would divide by negative 2. Okay, so in my formula here it says cosine squared t. So I'm going to need to square this when I plug it in. So if I square x minus 4, that would be x minus 4 squared over, if I square negative 2, that'll give us a positive 4 there. Okay, same thing over here. I need to solve this one for sine. So if I add over my 3, and then I can divide by 2. Okay, this says sine squared. This is just sine, so I need to square both parts. So we're going to have this plus in the middle. We have y plus 3 squared. In the denominator it's 2, so 2 squared is 4. And then we know it has to be equal to 1 because we're just filling in this formula. So that answer's fine, but normally with the circle, they have the same number on the bottom, so you multiply by that number to get rid of it. So I would write my final rectangular form as x minus 4 squared plus y plus 3 squared is equal to 4. Okay, so let's check with the information that we put on here earlier. So we said a circle has a radius, the circle has a radius of 2, so square root of 4 is 2, so that part checks out. The center we said was 4, negative 3. So this is x minus 4, so it would be 4. This is y plus 3, so it would be negative 3. Okay. And then just a practice graphing from earlier in the semester. If you wanted to graph this, you would graph your center of 4, negative 3. And then you would be counting up 2 spaces, over 2 spaces, and down 2 spaces, and then you could draw in your circle. Okay, so that's how you go from parametric to rectangular or rectangular to parametric for a circle. I do want to go back and mention something, so I'm going to go back to the last problem for a second. So on our last problem that we had, we ended up with the answer 1 plus cosine, or 1 plus 6 cosine t, and then 6 sine t. Those answers are perfectly fine. You could have other answers there, though. So when you take the square root, you could technically have plus or minus. So we could, if you would put 1 minus 6 cosine t, this also works here, okay? So this will give you the same radius here, it would give you the same center. So this would also be a correct answer. Over here, same thing. If you wanted to put y equals, because when you do the square root, you technically have plus or minus, negative 6 sine t would also give you the same answer. So, you're going to notice on all my answers, I just stick with the positive answers. But note, if they start out in parametric and you see these negatives here, it will all work out the same way because you're going to end up with the same radius there. So either one of those answers could work. So that's what it is for circles.